So at the time of recording, I've just released today, so it's episode 851, an episode on quantum machine learning.
Mm.
And in chapter one of your book, you talk about, as we near the physical limits of Moore's law, quantum computing could play a bigger role. I'd love your thoughts quickly on, it seems like you don't see quantum computing as just kind of this tack on, cute thing that's helpful in a relatively small number of scenarios, but potentially something more transformative.
I think that quantum is quite hard to get a grip on. Right? So when I wrote the book, Google had just announced that breakthrough with their Sycamore quantum chip, which I think it was a Sycamore, where they had done that that sort of toy test, lab test, where you generate random numbers, and it would take a normal computer quadrillions of years, like much older than the life of the universe, and it takes a quantum computer a minute. And then a few months ago, they announced the same breakthrough again with a big fanfare. But the people sitting around them had more certainty. I think the thing that we have to hold in our heads, John, is that people who are building quantum computers have come having been scientists, and scientists always see the world as it could be rather than as it has been. And so their framing of timeframes, I think, is different to you or I or most of our listeners who probably have products to deliver. So that's a roundabout way of my saying, I don't know when quantum computing will show up and be genuinely useful. If you have these quantum computers with the tens of thousands of logical cohered qubits or million logical cohered qubits that you need to do real quantum computing, I think really interesting things and amazing things will happen. But there was a while, and I'm sure you were familiar with this period of time, where for a couple of years people were saying, look, we're getting so many insights from quantum that we can start to simulate quantum on GPUs. And that is giving us kind of algorithmic tools to do things we couldn't previously do, and we would never have discovered that without quantum. I mean, that might be the case, but the other problem that you've got is that the world is being eaten up by the transformer architecture. Whether it's protein discovery, materials discovery, robotics, like this is the way to do everything. And so it might just be that there's more, that the intersection is not as big as we thought it was between quantum machine learning, that we have to just wait for quantum computers to be developed and delivered at that scale where it really makes a difference. And in the meantime, we can just do really, really well applying this transformer architecture and all the amazing chips that Jensen Huang and NVIDIA are producing, and that will kind of knock down the doors. So it's a really tough one. If I had to, if I really kind of summarize that in a sentence, it's continue to build quantum computers. It would be my view, but there's so much you can do with this AI wave that maybe there's a good reason to spend time there.
Yeah, very nice. Great answer. And yeah, if people want to dig into over an hour of discussion on quantum machine learning, what's possible today, what could be possible in the future, episode 851 is a great one to refer back to.